The assignment is a accumulation of everything we've gone over so far, from the stuff in the beginning about lines to the new stuff about exponents and powers and roots and solving equations, and then story problems that go with it. The first part of the assignment is pretty just general, what are these equations and how do we work with them? And the second page gets more interesting, where we actually have some problems with it that we have to figure out. So I just want to go over the basics of the first type of problems that we see. So for our final review, we've accumulated essentially 3 types of mathematical things. We have what I call linear equations or linear functions. Linear are things like y equals mx plus b. Example might be y equals negative 0.015x plus 0.982. So this could be like a blood alcohol equation right there. Big ideas about linear is we have this slope. That's that rise of a run. Slope is what we call a rate of change. Sometimes we use a formula, y2 minus y1 over x2 minus x1. Sometimes typing these things in that box where we have our form is hard. If I were to type this out, it would be more linear-wise. It would come out with parentheses, y2 minus y1 divided by parentheses, x2 minus x1. So it kind of depends whether I need the parentheses. Do I have a stacked fraction or not? If you don't have a stacked fraction, you got to have parentheses. When we solve linear equations, we solve them by using addition, subtraction, multiplication, and division. And that's it. They're the easiest kind of thing to solve. And we'll do some examples of this in just a second. So I just wanted to give you a quick overview, maybe some ideas of something you could post in the notes. Everybody needs to post at least one thing, but you can certainly post as much as you want. Again, the point of that notes page at the end is going to be to have a good set of notes to work with on that final exam. Next type of thing we worked with in detail were exponential functions, exponential equations. And the basic shape of those was y equals a times b to the power x. There were a bunch of variations on this, whether we talked about doubling time or increase or decrease, but they all had this basic shape right here. Important things here are the value b, and b is what we call a growth multiplier. It's different than the growth rate. We'll see that in a moment. A in this case is the initial value, the starting point, a Y-intercept. And we had lots of different examples of this, but one example might have looked something like this. So this might be a car depreciation where the car loses 15% of its value each year, but we keep 85%. So that was the idea of that. Remember that 1 minus r or 1 plus r is the base to the power. And so r in this case would have been negative 15%, which is negative 0.15. And when we do the 1 plus r, since r is negative, we end up with that 0.85. So this particular example, right, when I clean it, when I have the cleaned up version here at the top, matches that general form I have up there. We just had to work to get it when we were given the initial problem. So again, this example right here is showing us a 15% depreciation of a car. to solve this kind of equation, we need to use addition, subtraction sometimes, usually multiplication or division. Oops. And then the big thing we picked up here that was essential to solve for x was logarithms. And so that was kind of the bigger idea that we added on here, using a log to solve one of these for x. And just a reminder, what does a log do? It finds an exponent for us. And that's where we need them to get exponents when we don't know them. And again, we'll do a specific example of this in a minute. Next big type of thing we did were equations with powers like a 2 or a 3. So we'll look at those in a moment. And I will post my notes also this time, in case I go too fast here. And in the future, you can always look up the video and pause me. So we had other kinds of powers, and we had a few different examples of this. The first one was quadratic equations. And quadratic equations had all kinds of different variations. The general one, which we didn't look at too much, looks like this. And we actually looked at a simpler version, which was usually just y equals some number times x squared. Once in a while, we had an extra piece there, but mostly we looked at this right here. One of the last versions of this we looked at was from the braking problem, the braking distance. And we had a formula that looks something like y equals x squared divided by 54.4, maybe was one of the numbers we ended up with from a couple of weeks ago. In this case, since it's a denominator, that means the value I'm calling a up here would be a fraction, which is fine. It could be a fraction or a whole number. It's in the denominator, so we call it a fraction. To solve something like this, like with other problems, sometimes we have to add, subtract, multiply, or divide, as we've been doing since the beginning. And then the big thing we picked out to work with here was the idea of a root. This problem right here would involve a square root. But sometimes we had to use cube roots or fourth roots. So another example, volume of a sphere came up in a couple of problems. And that was 4/3 times pi times the radius to the third power. And to solve something like this, like above, we got to add, subtract, multiply, and divide in certain circumstances. In this case, just multiply and divide. But the idea of a cube root was important. Which looks kind of like a square root, but it's got a little 3 in that hook there to denote it's undoing a cube, not undoing a square. And then we had to make sure we're good at using our calculator to take a cube root. And some calculators have a cube root button and some do not. The alternative for the calculators that didn't would be the power 1/3 is the same as the cube root. then these roots are what we worked on the last couple of weeks. And that's the summary of the main math that we did, aside from, you know, little things like brushing up on some of our skills from previous classes. And then how to use a calculator to make all this stuff happen. So our three big ideas, mathematically, we're playing with powers, playing with exponents that are variable, and those are called exponents, right? Notice the difference. Here I have a variable power. And in the last set of examples, these have a fixed power or a constant power. Here the constant was 2, here the fixed power was 3. And then way back in the beginning, we played with these linear equations, and one of the biggest ideas there was the idea of slope and how we work with slope. So that's an overview of the main math we've done. The next thing was how do we apply it to different circumstances. So looking at our assignments for this week, we have our page 1, which is mostly just some algebra of those three different types. So we'll do a couple of those examples in a moment. The second page are scenarios that involve choosing one of those, linear, exponential, or power, and then using it to figure out what's going on in the situation. And then the last page on this homework were slightly more complicated versions of those kinds of problems that we'll play with here. So this assignment gets progressively harder on the 3 pages. And then the assignment after this one is pretty similar. It's just more of the same kinds of problems, but different examples of each one. And so that's that final practice. And then we'll do our notes. So let's just look at a few from the first part of this week, the lesson. Let's blow this up. And let's see, hello Alejandra and William. I didn't get to say hi to you guys earlier, welcome. All right, so let's look at this first one here. So this one says, what family is this equation right here? Is it a linear, is it an exponential, or a quadratic, which means second power? Well, there's no second power, so it's definitely not quadratic. There's no exponent as a variable, so it's not exponential. It fits the linear where we just have a multiple of x plus some other number. So the 4/5 is our multiple of x, so the 4/5 is our slope, and the 9 is our y-intercept. So I'm going to select linear there. Then we have two different parts. We're given an x value to plug in to see what happens. Then we're given a y value to plug in and see what happens. So I'm just going to show you how I would write that down. Get to the right page here. Okay, so here's our problem. I believe it's linear because it fits that form we talked about, y equals mx plus b. And so here, it didn't ask me to do this. I'm just going a little farther. The m is my 4/5, that's my slope. And the b is 9, and that means the point 0.9 is the y-intercept. And knowing the difference between the slope and the y-intercept is going to be useful on some of those harder problems in a minute. Once I've established it's linear, it says, all right, put x in and see what happens. So let's give that a try. So they didn't give me y, they gave me x, so I would say y equals 4/5. And when you substitute into an equation, it's a good idea to put parentheses when you put it in. And then here, since everything's on one side, I just apply the order of operations. So I would view this, and again, you could just whip out your calculator on this if you wanted to. I'll do that in just a moment. I would view this as 5/1. When you multiply fractions only, you can reduce ahead of time. 5 goes into 5 once each. And so 4 times 1 divided by 1 is just 4, plus 9 is equal to 13 on a good day. And when you're taking the test, you definitely want a calculator and or a spreadsheet nearby. So let me whip out calculator. Let's play with Desmos today. Desmos has the nice feature that when you hit divide, it turns it into a fraction, which is mostly good. Sometimes it's a pain in the butt, especially on my phone with those little teeny buttons. And so I'm just going to type it as I wrote it on my paper and pray it works out good. All right, so again, we need to be masters of our calculator. So I think the answer here ought to be 13. Next one, they gave us y. That's going to be a little bit more work. So y is 6. And so replacing that with the y here, I get 6 equals 4/5 x plus 9. Now, solving an equation is backwards of plugging into an equation. You have to get the furthest thing away first. So I would get rid of the 9 first. It'll make things easier. So I would subtract 9 from this side, subtract 9 from that side. This side's easier. Let's see, 9 minus 9 is 0. 0 plus 4/5 x, well, that's just 4/5 x. Adding 0 doesn't really change that, does it? And then 6 minus 9, I had 6, I lost 9, that means I have a -3. And again, that might be a good thing to do on the calculator, because I don't know about you guys, but one of my most common mistakes is to mess up a sign on something. And so definitely on a test, we're not just going to think it, we're going to check it. So whip out the calculator and say, is that really true? If I typed it right, calculator agrees with what I thought. All right, now here I have a couple options. I could divide by 4/5, that's one version. I'll show another. 2. And then you got to remember that when you divide by a fraction, that means you multiply by the flip, the reciprocal of that. So that's the same as -3 times 5/4. Okay. If you weren't sure about that, plug it into a calculator. A fraction within a fraction can get kind of messy on a calculator, so we'll do that in just a sec. So here I view that as -3/1. Negative times a positive is a negative. 3 times 5 is 15. 1 times 4 is 4. So I could give the answer as a fraction, -15/4 here. Or I could turn it into a decimal because dividing by 4 is not that bad. The other way to think about this, alternatively, -3 equals 4/5, is to just straight away, when you're working with fraction multiples, just multiply by the reciprocal. So I could just take 5, so I'm going to switch colors, take 5/4, right, flip it and multiply on both sides. Because then here I get 20/20, which is 1x or just x. And then on the other side, I get what took me 2 steps to do before. All right, so both have their advantages. But let's check this on a calculator to be sure. So here, let's see, I could use maybe the fraction button first, put the -3 in the top, and then go down to the bottom, and then try to type the 4 divided by 5 and hope it gets it right. Desmos gives me the decimal version. It says you could convert to a fraction if you want, and I can see, yeah, I got the same thing. But using these are called complex fractions when you have a fraction within a fraction. Sometimes it's hard to tell what's the main fraction bar. And just let me zoom in. Not really, a little bit. Oh, that came out weird, didn't it? You can kind of see here that the fraction bar under the -3 is a little bit bigger than the fraction bar with the 4/5. So that's the main fraction. Okay? And it's important that we get that right, otherwise we'll get the answer wrong. And that just takes practice. All right, let's zoom back out there. Maybe there. So, and then whenever we click on these boxes, we should pay attention to what it says, and then it gives examples to make sure we're typing it right. Now, typing in 13, that was no big whoop. But the next one, it says enter a mathematical expression, which means I could enter a fraction or a decimal. Okay, so you could enter either version here and it would be okay. If it says no decimals, then pay attention to that. But this one does not say no decimals. So I could go either way on this one. I could do the -15/4, or I could do -3.75. So again, pay attention to the fine print. And let's get a green check. Nice. All right, so yours would be similar if you're following along, or if you're just taking notes, that's cool too. Let's look at the next one. What family is this one? Hello, Tia. Exponential, linear, or quadratic? Anybody want to chime in on that?
Exponential.
Yeah, it's exponential because the variable is an exponent, okay? Excellent choice. So we got exponential there, and then we'll go and play with it. So let's copy this. Here they tell me give your answers to at least 2 decimal places. Again, read that fine print. Every once in a while I miss that. My wife says it's a guy thing. I don't know. All right. Copy so we can scribble. Oops, wrong page. All right, so we think we identified the type, and just a reminder of our basic form of an exponential. I wrote earlier, y equals some number I call a times b to the power x. In this case, b is my base, that's 2. I called that a growth multiplier. It's also the base of the exponential. And we'll see, it's supposed to be an I. I'll remind you later why I call it a growth multiplier, not a growth rate. And the 6, that value I called A, in this case, that's the initial value or Y-intercept. Just a side note there, we're asked to plug in X and see what happens. That one's pretty straightforward. So we just put 9 in there as the power. And in this case, I'm just putting parentheses around the 9 to remind myself that's the number I'm plugging in. And this is a good place to do a calculator. I really don't want to do on paper 2 to the 9th power. It's fun, but not that much fun. All right, so new line here. I have 6 times 2 power button to the 9th. And I'm getting 3,072, and it looks like I typed it correctly. If you have any doubts, try typing it again to see what you get. So 3,072 for mine. I get that right. And always double check that you typed it correctly. Every once in a while I do typos, and I think so. Next one's a little bit more work. So I'm just going to make a note what my calculator said. So here I'm plugging in y, so that's going to give me 9 equals 6 times 2 to the power x, and I have to solve for x. All right, so in this case, again, when we solve, we get the things that are furthest away, which is we have to get rid of the 6. Since the 6 is connected by multiplication here, we're going to divide by 6 to get rid of it. And when we do that division, right, on one side, we have a number divided by itself, which is 1. 1 times 2 to the x is just 2 to the x. That doesn't change. But the 6 is gone. On the other side, I could leave it 9/6, or I could throw it into a decimal. So at this point, I might go over to my calculator and say, hey, what is 9 divided by 6? And my calculator might give me a nice answer, like 1.5. If it gives you a decimal that goes on and on and on, we might want to leave it as a fraction. So this one, the decimal's not bad, so I'm going to go with it. But if I had something like, let's say 2/3, that decimal goes on and on and on. That could lead to rounding error. I might want to just keep it as a fraction. Okay. Just a what if. So I'm going to go with the 1.5 since it is a nice number. But again, beware of decimals that go on too far. Fractions are sometimes better. Now at this point, once I get the base to the power alone, I'm ready to use a log. So what I do is apply log with parentheses to each side. The one power of using a logarithm is it pulls the exponent out. So then I can rewrite that right side as x times the log of 2. Now, log of 2 is just some number. So if I just double check with my calculator on that, let's see, the log button is hiding over here somewhere. There it is. Oops, wrong spot. Log of 2. It gives me this decimal that goes on quite a ways. Different calculators will give more decimal values. Again, at that point, I want to be aware of rounding error, so I'm just going to leave it as log of 2 for now. Since it's connected by multiplication, I can move it to the other side by just dividing by that whole log of 2. And we've done this a lot before. On the right, when I take a number and divide by itself, that's always 1. So I now have 1x on the right side. So x equals this fraction over here. So that's my final answer right there. And I'm told to round to 2 decimal places where necessary, so I'm going to round that. Now I go to the calculator and do the whole fraction. So I'm going to type my log of 1.5 is the numerator log. Make sure you close the parentheses, super important. Then divide by the log. And if you're using a different calculator, again, you got to get used to how your calculator works. But closing parentheses is important in a lot of cases. So I get log of 1.5 divided by the log of 2 is 0.5849, blah, blah, blah. If we had used the rounded version for that denominator, we'd have a slightly different answer there. Right, so just for comparison, what if I had log of 1.5 divided by, but I used maybe 0.301 instead? Will that cause a big difference? 5849 versus 5850, rounding to 2 decimal places, that makes a difference. So I might get that wrong if I use the rounded values. So I think the second way is not a good one. The first way is the better. So I would say to 2 decimal places, my answer is 0.58. I'm just going to put that in my notes. And whenever you use your calculator, write down what you do, write down what the calculator says. So, oops, I missed something, 5849, there we go. And then rounding to 2 decimal places is just going to be 0.58. There's no decimals in the answer above, right? We just did the 3072. So try to avoid rounding till the end whenever possible, which means sometimes you got to work with fractions or weird things like a log of a number. Questions on that example? Okay, moving on. Just for fun, let's get some green check marks. It feels good. All right, what is the family of the equation y equals 4 times x squared, x to the 2nd power? Anybody want to take a shot at that? Oh, I lost my chat screen. Where did it go? Oh, there it is. There we go. Okay. Nobody wants to tell me what they think that is.
Is that quadratic?
It is quadratic. Ah, thank you. A bunch of people telling me. Yeah. So it's not linear because there's something happening to the x besides the multiplication. It's not exponential because that would mean the exponent had to be a variable. So it turns out this one is quadratic. It's possible it's none of the 3, but yeah, because of the 2nd power, it's quadratic. That's the key about quadratic. Looking back at my notes before, when I was identifying some of those things I called power expressions, a quadratic is something that has a highest power of 2. So this volume equation down here is not quadratic because it has a power of 3. So this one right here is not linear, It's not exponential, it's not quadratic either. It's sometimes called a power equation because it has a fixed power. This one could also be called a cubic, but that wasn't one of my options or the problem we have now. Again, this one is neither quadratic, exponential, or linear, but the one we have here, definitely quadratic. When we work with quadratics, we have to use roots. So let's play around with the two things we were asked. And this says there might be multiple answers, separate them with commas. So get to a blank page. Screenshot. All that. So on each of these types of questions, the first one's the easier one. We identify it. Once we identify it, we get another kind of easy question. We just plug in and see what happens. So what is y if x is 7? So I just write down 4 times parentheses 7 and then the second power. And I can pretty much enter this into my calculator as I typed it to get an answer. And definitely use a calculator all the time. Even if you can do it in your head, double check with a calculator for a test. Calculator here. So new line 4 times, and I use parentheses in my notes, so I'm going to put it here. Turns out I don't have to use them. 4 times 7 raised to the second power, I get 196. Drop that in and put it in my notes too. And again, when you take the real exam, write down as much as you can and number like which one you're on. I have not done that, I've been naughty, but I should say, hey, this is number 3 on this assignment. And I don't really need intermediate steps, I just use my calculator, so I'm just gonna jump right to the 196. Next one's a little harder. I have to plug in a 3 for y and then write the rest down. So here, I think I want to solve for x, and I have to get rid of a 4 that's multiplied and a 2 that's a power. And the easiest thing to do first, I think, is get rid of the 4. So I would break that multiplication there by dividing by 4. 3/4, double check on the calculator. As a decimal, that's not bad. It only has 2 places, so I'm just going to go with that. But if you wanted to leave that as a fraction, you could. And then a number divided by itself is 1. 1 times x squared is just x squared. Now, to get rid of the square, I take the square root. So at this stage, I would just write square root on both sides over everything. A square root cancels a square on one condition if on the other side you put a plus or a minus. That's important. And otherwise, I have to ask my calculator what's the square root of 75/100ths. But this is super important. When you take the square root of a square, you've got to have a plus or a minus. So here, x is equal to the positive square root of 3/4, 0.75, or the negative square root of 0.75. So we just need to know to what 2 decimal places, and it says at least, so I could put more. What is the square root of 0.75? And again, I definitely need a calculator for that because I don't know it off the top of my head. Square roots are very difficult to do without a calculator. So square root button, 0.75. And the calculator says 0.866. It said to use at least 3, so I think I'm just going to go with the 0.866. I mean, it said to use at least 2, because that rounds easier than the other one. So I'm going to say that this is about 0.866, and then the other one, it wants me to separate with commas, would be negative 0.866. And sometimes they work out pretty nice like that. One's positive, one's negative. But we have to have that plus or minus when we take the square root of a square. Just going to make a little note about that. Plus minus when we take square root of a square. And the reason we have to do that, square, is because when you square a number to get a result, you lose track of whether it was positive or negative. right? So simple example, if I take 2 and square it, I get 4. If I take -2 and square it, I still get 4. So if I told you I squared a number and 4's got to be the answer, you could say, well, either x is 2 or it's -2. So because when we square stuff, we lose the sign, we got to compensate when we solve by throwing in a plus or a minus. So my answers here would be 0.866, comma, -0.866. And you'll have a slightly different set of numbers, but it's the same idea. And I can get away with 3 decimals because it said use at least 2. Alternatively, 2 is at least 2. You could have said 0.87, comma, -0.87. And the order shouldn't matter. You could do the -1 first if you liked. All right, let us plug that in to get another green check mark. Yay. The next few equations are just repeats of what we did up there, just for you to get more practice. So I'm going to leave that. So I've done one of each of those. The next 4 are similar with slightly different numbers. Stop the recording here and make a new one.